All right. Hello, my name is Ben. This is part 4 in a series where we are implementing a DSL for UI testing in Rust. And today's episode is going to be about parsing. So in the last 2 videos, actually, we built a scanner. And the job of a scanner is to take in some source code as a string and turn it into a list of valid tokens. A token is this programming concept, which is sort of like a programming language's version of a word. It's basically just a distinct entity that has some sort of semantic value in the language. What we're going to do now is we're going to build a parser, and the job of a parser is to sort of scan over those tokens. Shouldn't use the word scan because there's such a thing as a scanner. Is to take that list of tokens and turn it into some sort of tree. We want to describe the shape of our program so that eventually we can walk over that tree and execute something, or at least produce some sort of other thing that we can execute. Very seldom do you actually just want to execute the tree. Most of the time you want to turn it into like some kind of bytecode type representation of something. But that's what we're going to do today. So let's keep going. Okay, so let's see. What did we do last time? In the last video, I did say we were going to look at the docs, and then I never did that. So I'm just going to produce the documentation for our project. So this is just, I wanted to show cargo doc. If you're not a Rust person, this is the sort of standard documentation for any Rust project. Cargo doc is really great for a lot of different reasons. We talked about earlier how if you have some example code in a doc comment, in a comment, that code will actually be compiled as an integration test. And what's nice about that is it encourages you to write documentation because your documentation can also serve as a test, sort of a two birds, one stone situation. And so I'll show you that. We made the scanner yesterday, so you can see we have a scanner, and then we have a token, and then we have this enum token type. If we look at the scanner, we gave it this kind of example, right? So here's the declaration for the scanner struct, and we have this example documentation, right? And RustDoc produced this little example snippet for us. But this actually gets compiled as a doc test. So you can see VS Code is telling me, do I want to run this doc test? So I'll actually click that. But you can do the same thing by running cargo test or cargo T, just to execute all your tests. But you can see it says one test passed. What passed is the fact that this code compiled, right? This code compiled successfully. And so we know that the example in the documentation is up to date. Now let's say I wanted to, we mentioned this earlier, let's say I make a change to the scanner function. And basically what we have here is a constructor, right? This is a function called new that's going to return the object, right? It's going to return a scanner object. But most of the time, when you call new on something, you expect it to just sort of not take any parameters, to build an empty version of your struct. But a scanner needs source code. It can't construct it on its own. The whole point of the scanner is that it takes your source code and it scans it for you. So we could call this method, let's say, from source, right? So you can construct a scanner from a string representation of your source code. So let's try and test this. So I'm going to run cargo T, And you can see we have a failing test. Thing is, we don't actually have a real test suite yet, but what we do have is a doc test, right? So our doc. See, we have doc test schnauzer UI, and this this line fails 4635. So if we go to line 46, right, this fails to compile. And the reason it fails to compile is it says function or associated item not found in schnauzer UI scanner, right? It doesn't have an associated function called new. What it does have is an associated function called from source. So now if I test again, you can see our tests are passing now. I felt that was worth highlighting twice. It's a really great feature. The other thing is that Cargo Doc automatically interlinks your documentation with the documentation of other libraries that you're using. So for instance, the standard library, right? You can see here, this is actually the previously generated version. So let's regenerate our docs. So that you can see now the scanner has this from source function. If you were to use somebody else's code, right, the only code we're using right now is the standard library. If you were to use somebody else's code, their documentation gets interlinked. So for instance, this from source method takes a string, and if I click through on that, it takes me to the live documentation for the Rust standard library. It tells me about strings. That's really nice too, especially for libraries that maybe re-expose the functionalities of some other crates, or just tell you to go ahead and add that to your project too and use it. They will. It's really convenient. It's really nice. Just wanted to brag on that a little bit before we got going. Okay, let's start making a parser. So let's do parser. That's a folder. I did not mean to make a folder. New file. There we go. Okay, let's make a parser. We're going to need a couple things. So the point of the parser is to produce some sort of syntax tree. The first thing we need to know is, what does that tree look like? Basically, we need a coded version of our language grammar. So let's do that. So we have, if we look at our sort of initial grammar, we have statements, right? Each one of these lines is a statement, and a statement is some expression, and then that expression can be followed by 0 or more other expressions separated by the AND keyword. So let's do that. Let's make that. So let's have a pub enum. Well, really, we don't need an enum because there's really only one kind of expression in our grammar. So we can just have a struct expression, right? And before I get going, let's pubmod parser. Great. Okay. And that's going to have two things. Well, actually, there are a couple ways we could represent this. I think basically it's got to be recursive. So in the sense that we can type the keyword "and" any number of times, right? We can say locate username and type @test.com and type something else and maybe click it for some reason. So I think this should sort of be a nested expression situation. So we can say it has a left-hand side, right? And that's going to be an expression. Well, okay. Oh, this is a statement. We're defining a statement. I was like, why would we have to box that? Okay, so a statement can have an expression on the left-hand side, and then it can have optionally an and keyword and another expression. Now, do we want to say, we could do it like this. We could say pub and, right? And that's going to be the actual token. Actual token that we find there. And that would be an option. Right, we don't necessarily say and. And then we could have pub right-hand side, which would also be an option, expression. I think we can go with that for now. It may be the case that we want to sort of wrap up the right-hand side in a single way. This sort of seems to well, let's change this up. I don't like the way that this implies that it's possible to have an and keyword and no following expression, or to have a right-hand side expression and no and keyword. So I think what I'd rather do is call this and expression, and we'll say you can optionally have a token and an expression, right? You should have both of them. You should never have just one. I think, and we'll call this right-hand side. And then this expression, if we had multiple and chains in a row, this expression is what would contain the right-hand side of this expression would contain the next part of that statement. And then when we execute the expression, the way we'll do it is we'll sort of walk down, we'll execute the left-hand side, and then we'll decide based on the result of that whether or not we want to go down the right-hand side. Yeah, I think that's a good definition for our statement. Okay, but now we need this thing expression, right? We have pub struct expression. Okay, well, let's look at what an expression is in our grammar. The way we have it defined is we have it as a command followed by either it can stand on its own, or it's followed by some input. And right now we're only supporting commands that take one input. We don't have any commands that take more than one parameter, basically. And I think the idea was not to have global variables be this sort of, obviously a global variable is something that's going to evaluate to something. Like generally it would be considered an expression in the computer sciencey version of the word expression, but it for us personally, I don't know that we need that. I think we decided that we would have a command called had error, and then we could really just have, you always have to have some sort of command, and then that command can optionally be followed by some kind of input. I think that's the way to go. I think that's what we're going to do for now. So for our purposes right now, an expression is always going to have some sort of command. We'll call that command. And then it's optionally going to have an input. But here we go. So some commands take inputs, some commands don't. So we really just need to store the command. So I don't really think there's need for this internal. Let's not be confusing by calling something an expression. Let's just call it a command, right? And let's call this a command, right? Okay. But now we have multiple different kinds of commands. So let's make this actually an enum, and then the commands can have an associated string for any input that they take. So what are our commands? Well, if we go look at our tokens, it's basically this. Right? These are the supported commands in Schnauzer UI. We can locate an element, and that's going to take the string. And this is part of why we didn't. Document the command variants on the token earlier. We'll still probably go back and do that, but I think this is the place to specify what each command does. And then in the token type enum, we'll just sort of say this relates to a locate command and then link to it. A locate command. So this command is for resolving basically a locator to a variable. To a web element. So basically the idea of this command is that you can say locate and then give it some sort of locator, like an XPath or something. And it will, first of all, decide what locator it is you're actually trying to use. Or really, we'll get more into that when we get into interpreting, actually executing the code. And then once it does that, it should sort of give back it should locate that element based on the locator you provided and give back a web element. That's what this does. So we can say the associated string is the provided locator argument, right? And there's an argument to be made that these should be structs. It's actually a very common pattern to like. What we could do is we could have a pub struct locate command, right? And that would have pub locator as a string, and then this could take locate command, right? That, I don't know, for right now, I think each command only takes one argument, and we can sort of document here what argument it's going to take. When you start to get enums that maybe have 2 or 3 associated values with them, I think it's a good idea generally to break it down into structs. It's a little bit more organized, and it's also like a really good place to sort of attach documentation to. So it gives you for each of the fields of the sort of associated struct you're giving it, you can document that field, right? And then you also get to sort of do a general documentation of what this is about here. For us, I just don't think it's going to be all that complicated. So let's just do a string, and let's have a comment on the enum variant that lets us know what the heck this is about. Okay, we have a type command. This is a command for typing text into some web elements, right? Into some web element. And we'll say the associated string is the provided text, right? We'll give it a string. Okay, cool. Click. command for clicking a web element. Right? And it doesn't take any parameters. If you're wondering right now, if click doesn't take any parameters, how does it know what to click? Let's look at the example from here. If you look at our grammar, we sort of do this thing where we call a locate command, and then we call some actions, and then we call another locate command, and then we call some actions. So basically, as part of our runtime for this language, we're going to sort of have like a current element, so sort of one element in view at a time, and any sort of issued commands will apply to that web element. So the type command doesn't take an element argument, because it's just going to apply that type command to whatever current element is in focus for us, basically. Okay, we have report. This is command for printing to a report log. We haven't really talked about how we're going to implement, like specifically what the reporting is going to look like, but that sure is going to take a string for reporting. Okay, refresh for refreshing the current, for refreshing the web-driver. And the idea is that each one of these scripts is going to get, basically their own WebDriver to run against. We'll have a standalone Selenium grid running, and for each script that you run, we'll register a WebDriver against it, and then they'll all sort of execute in what's the word I'm looking for? Not parallel. They'll execute concurrently, basically. Okay, try again. Okay, so this command is interesting. The try again command lets process know to start over after the last error handling line. And there's a little bit of ambiguity there, because what if we do a line where we do some like error handling and then maybe we do some element locating on the same line? I think we might want to produce an error in those instances, but we'll see. Okay, and then obviously the screenshot command for taking a screenshot. And then the had error command. This is interesting. This is a command that basically, this really is an expression in the sense that it's just gonna evaluate to a Boolean. The only reason we've elevated it to the level of a command is so that we can sort of simplify our grammar a little bit. So we'll say a command that evaluates to a Boolean for if there was recently an error. So let's be more specific about that. If there is an unhandled error, right? We have these sort of error handling lines, and when we handle an error, we should sort of reset that, and then if it gets set again, then had error will return true. Okay, and then read to. This is a command for reading the text of a web element to a variable, right? So the idea here is that we can have you can, like, say you're doing some sort of process on the web page and you produce a unique ID for something. You obviously can't predict what that's going to be, so you can't just have it saved ahead of time. What you have to do is you have to read it to some sort of variable so that you can use it later. We also don't. It's worth noting we don't have a way to sort of manually set variables in our syntax yet. I think we'll eventually add that along with a lot of other things. But for now, we kind of want to get up and going, and then we'll sort of add things in waves later on. Okay, so these are pretty much our commands. And so yeah, so the job of the parser now is to basically take a list of tokens and turn them into a list of statements. So let's make a parser. Pub_struct parser. And again, we're going to sort of do this in a sort of Java-y way where we have a constructor that's basically just going to take the list of tokens, and then we're going to have another method that you call to produce the syntax tree. So let's do, yeah, let's say function, we'll say from tokens, we'll keep with the pattern we set earlier. And tokens is going to be a vec of token, and it's going to return a self. Oh, I thought I was in the impl block. I always do that. Impl parser, there we go. We know we're going to need tokens. All right, so let's go with that. Okay, and this is going to say self tokens. We know we're going to need, it's going to be very similar to the scanner, where we're going to have a sort of, we're going to have a buffer for, interesting. Yeah, we'll have a buffer for collecting statements, basically. So we'll say, let's call this statements. This is going to be a vec of type statement. And we'll say that's going to initialize to an empty vec. Okay. And then, yeah, let's go from there, and we'll sort of add things that we need as we go. Okay. Pub function parse. And parse is going to take mutable access to self, and it's going to return, presumably, a vec of statements. Okay. So the idea for us is that each line was equivalent to one statement. So we could go through and say, if we don't reach the shape that we're expecting, if we get to the, basically we already know that we've split our code into lines, and we know that those are supposed to be our sort of statement boundaries. And the reason that those are our statement boundaries is because we kind of want to execute each line one by one. That's going to help us with like step through and whatnot. So let's have the scanner help us out a little bit. So if we look at the scanner, we have an end of file token. Let's have an end of line token. I mean, why not, right? End of line. And then when we're scanning, after we've scanned a line, let's push an end of line token. I don't know if this is standard. I don't know if other people do this, but why not, right? Self dot token type end of line, right? That seems to work. And then in the parser, we can basically split on the end of line token. So we can say for statements in, not statements yet, right? We want to parse them into statements, but for, we'll say line in self dot tokens and split on a token such that the token type is token type end of line. Then we can say something like self dot parse statement, parse a single statement, and we pass it the line, which should be its own little, yeah, like a slice of tokens, right? We'll say let statement equals self dot parse statement line, and then we'll say self dot statements dot push that statement. Easy enough, right? Okay. And then at the end, we will return self dot statements dot clone. Right? At the end, we'll return the vec of statements. Method clone. Okay, so we got to do a few things. This is sort of handy derive. We want our statements and commands to derive exactly the same. Right, there we go. Okay, we need to import token type. Create token type. Cool, and now we just need a method parse statement, right? And let's have function parse statement and read self and takes, yeah, so it takes, we'll call it a line because we're not really keeping track of lines in the parser. That sort of we're not keeping track of the actual line in the source code in the parser. That sort of information lives in the tokens, although we are technically, I mean, theoretically, we're still splitting by the lines. And that's going to be, let's have it take a vec of tokens, right? And then we can call toVec on that. Hey, look at that. Great. Okay. Now let's start parsing. So we have a vec of tokens, and we want to start parsing statements. A statement is going to be an expression possibly followed by an and sign and another expression. 0 or more times. So I guess the first thing we want to do is we want to parse a single expression, right? So we'll say let the left-hand side be self.parse expression. And we'll say, okay, so usually the way you would implement this would actually be that you had sort of had indexes, right? You had like we started to do on the scanner, but we didn't feel we really needed in the end. Where you have a sort of start and a current on the tokens, and so you sort of walk the tokens and do look ahead. I think that's probably fair. So what I'll do is we'll say we'll have a sort of current line be a vec of tokens as well. And we could, we'll start that off as an empty vec. Now theoretically it would make sense to have that be an option vec token, but I think for right now an empty vec should be fine. Okay, and then we could have this basically, rather than pass the line as a vector to the parse statement function, we could set the line as the current vec and then call parse statement. But I think I like the fact that parse statement takes the line because it sort of forces you to think about what you're currently parsing. And then in here we can just say self.currentLine equals line. I think I like that better. Okay, and then we'll call self.parse expression. And then, so we'll have a left-hand side for a function parse expression. Then we need to do the right-hand side. So basically, we want to have some sort of function that we want to be able to do look ahead in a couple different ways. So let's have something called let the and token, right? Where we're looking for an and token equal self dot, let's call this advance on, yeah, let's call it advance on, and we'll say token type and then after that we can say, and the idea is that this method is going to basically return an option token, and so if the next token is an and type token, then we'll advance on it and sort of consume it. But if it's not, then we won't advance the cursor. And then we'll say if let some token, yeah, better yet, we'll say it like this. Let right hand side equal self.parseExpression. And then we'll say left-hand side equals and then we can return a statement which has, right, remember, what are the fields on statement? Has a left-hand side and a right-hand side. So if we parse an AND token and a right-hand side expression, then we should say, then the statement we're returning is, we use left-hand side as the left-hand side, and then right-hand side is that AND token and then the right-hand side expression. That's a little confusing, and then otherwise we basically want to return a statement. Oh, and this is supposed to be an option, right? Otherwise we just want to return the left-hand side, and the right-hand side is going to be none. Yeah, I think that makes sense, right? So imagine we're looking at, we'll say parses a statement, and then imagine we're looking at the statement locate submit, locate the text submit, right? Where we've got a statement where we're basically trying to say, hey, I just want to verify that the submit button is available and like displayed. That, in that case, would be this, right? A statement with a command on the left-hand side, right? We've got the locate command that takes that string. But if we encounter an AND token and say click, right? Then what we want is after we parse the expression on the left-hand side, we want to say if the next token is some AND token, then we want to try and parse an expression from the right-hand side of that, and then we want to return this statement, right? Now, really though, if we look at this, this right-hand side so like error status and screenshot, that is a statement. We don't really have, like, we could just type the command screenshot and that would be in itself a statement. We would call that an expression statement, I guess. So maybe we should maybe we don't want to call parse expression. We want to call parse statement again to try and get the rest of it, right? So in our grammar, a statement is an expression and then basically followed by the AND keyword in one or more zero or more statements. I think that's what we want to do. Yeah. I mean, they're both sort of equivalent semantically, right? An expression followed by 0 or more expressions. But really we could call this like, right, an expression, and then optionally you can type and have another statement. And that statement would itself be the idea of an expression, and then maybe another and in a statement. Yeah, I think we can do it that way. So let's parse statement, right? Argument of type. Oh, and it takes the vec token. Okay. So now that we're doing this recursively, we don't really want to be passing in this line value. Instead, let's do what I said I didn't want to do earlier and say self.curline equals that, right? And then we parse statement. Expected command. Oh, and we decided on a different grammar, so we have to change our grammar. Yeah, I think we were wrong before. I don't think that really only allows for one extra and what we really want is the idea of, you know, sort of infinitely trailing. Of course, it's going to get mad at me now. It's going to say recursive type statement has infinite size, right? So basically, we can't, you know, that just sort of runs out of memory, right? Because you can have as many statements nested as you want. So basically the way to fix this is we just sort of give it some, we use indirection. We put it behind a pointer. We're going to put it behind a smart pointer called box. Yeah, and so now it only has to store a pointer to the other statement. And so it doesn't get, it still balloons in size, but not in the same spot, if that makes sense. Okay, so then down here, we want to say box new right hand side. Okay, I think that's where we want to be. Now we need two functions. We need advance on, that's going to sort of look ahead and say if the next token is what we're looking for, then we're going to sort of consume that token. And then we need a parse expression statement. So let's do advance on first. I think what we need is we have this sort of current line that we're, and really, do we even need tokens? We could do this. We could get rid of tokens. Get rid of tokens, and let's have parse take tokens like that. Yeah, right. I think that makes the parser more reusable. Let's see, we set the current line based on the past vector, and yeah, we'll see if we want to reuse that in the future. The only thing we'd have to do to make this fully reusable is we would want to clear the statements vec at the end of the parse method. But yeah, let's do that. Let's do let statements equal self dot statements dot clone, and then we'll do self.statements dot, what is it? Is it clear? Is it empty? Yeah, clear. Right, and then we'll return the statements. Right, so after you parse one list of tokens, you should be able to just call parse on a different list of tokens, and that might make this parser struct more useful for someone trying to build it into their own software, right? Okay, now we need, I think we need a current token index. It's going to be a usize. That's going to basically tell us what token we're currently considering in the current line that we're parsing. And then we're going to start that at 0. Yeah. Cool. And then let's do a function called advance on. So we need, keep it private, I don't think anyone's going to need advance on. Advance on, and it takes a token type. Right? And what it's going to return is an option token. So basically what we're going to look at is we're going to say if let some token equal self dot current line dot get current token. Right, so basically current line is a vector of tokens, and we're saying if there's a token at the current index we're considering, then that's going to give us this token. And then I think, can I do stuff with token on the same line and because it would short circuit token dot token type equals the provided token type. Can I do that? Let expressions in this position are unstable. Okay, so yeah, it's a feature called let chains. It's not really a good enough reason to opt into an unstable feature. So let's just do this. We'll say if there's some token there, basically the reason it might return none is it would say that index is not within the bounds of the vector. Like you're either past the end or you've provided some negative number. Then we're going to say if that token has the same token type as the one provided, then we are going to increment our current index, self.current token plus equals 1. For some reason, Rust doesn't seem to have plus plus syntax. So like you wouldn't do plus plus I and you wouldn't do I plus plus, as far as I know. Like if I have 0 plus plus, right, that's not, it says error, syntax error expected expression. And if I do plus plus 0, yeah, I don't know why it doesn't have that syntax. But I mean, it doesn't really matter. Plus equals 1 is fine. And then we want to return the token. So let's do let's just return the token. We got it. Token dot clone. Yeah, because we have a reference to it. We'll say some token dot clone. We have to say return because we're sort of in these nested loops, and then down here, if none of that happens, we'll say none. Yeah. So basically, that should let us look at the token we're considering next. And if we find the token type we're looking for, then we'll sort of consume that token. And if we don't, we won't really do anything about it. Okay. Yeah. Now we need a function called parse expression. Pub function parse expression and mute self, and that's going to return an expression. And there is some sense that like eventually we're going to have to upgrade these signatures to return results, right? Because it is possible to mismatch the grammar, right? So let's see. We want to try, how could the previous, so left hand side equal parse expression, and then if let sum and token self.advance token type and, then we should get we should consume that and then try and parse a statement again. Otherwise, the sort of base case is that there is no trailing and we get a we return none for the right hand side. The one thing we are missing is if then. So we had this idea that we would have if then desugar to an and I think we can deal with that at a later time in this video. Okay, let's keep it moving. Parsing an expression. Well, an expression we should be looking for a command, and based on that command we might be looking for some input. So this one's going to be a long one. So let's do if let some token equals self dot advance on token type. So let's look at our commands. The first one is locate. Locate. Then we want to do self dot. We expect that locate takes. Locate takes a parameter. You can't just call locate. You have to give it some sort of locator, right? So we want to advance on a token type of a string literal, right? Advance on token type string. Okay, so now this is interesting. Okay, so we have sort of two issues here. The first thing is that if we don't find a string following the locate command, that should be an error. So what we kind of need is another method that's like advance on or error, which is basically the same as advance on, right? But it should return a results token and then some kind of error. For now, we'll do an empty tuple. And this will be advance on or error. And then the idea here is that this is going to be okay, we've got the token we were looking for, or we're going to return some error. And right now we're doing this sort of empty tuple error. But if we don't find the token we're looking for, we need to propagate that error, and then we need to decide where to handle it. There's this concept of synchronizing, where if you don't, if you find some kind of error, you want to try to get to the boundary of the statement. So like if I typed some code, like, I'll just type it up here. Let x equal and 43L, right? There's an error in this statement, but we don't want the whole program to like crash. We don't want to stop reporting errors. So what we want to do is sort of try to get to the statement boundary. In this case, the statement ends at a semicolon. For us, a statement as we've defined it sort of ends at the line. So I think it should be good enough for us to sort of propagate that error to the parse, to all the way up until we catch it in the parse function, basically, and say, hey, processing that line resulted in an error. So let's report that line as an error, right, as a static error, and then let's keep parsing. So we'll propagate that error, which means that this returns a result, Control Z, a result expression, and then our very detailed custom error type, the empty tuple. And you should be we can probably clean this. We'll clean this code up later. Self.advance on okay error type. Parse expression. If let some token equal advance on. Yeah, we're just not done with this yet. Okay, cool. And then the idea at the end of this. Idea behind parse expression. Yeah, I guess we'll have an error at the end there. Okay, and so we propagate that. What's your deal? Can I find type expression in this? Oh, that's right. We don't call them expressions. We call them commands. You know what? Let's call them expressions. Well, call it command, and we'll call this parse command. Right? I want to be careful with, I don't want to use sort of like compiler and interpreter like terminology too much, because I don't want to use it incorrectly. I probably already have in this video. Okay, but we're going to propagate that, and then we can say propagate that, and then this is a results statement error, right? And then we can propagate that, and then this will be wrapped in an OK, and this will be wrapped in an OK. And then from there, parse is what's going to handle this. So we're going to say we're going to say match self.parse statement. And if it's okay some statement, right, if we get an okay statement back, then we're basically going to push that statement to our list of parsed statements. And if we had an error, E, we haven't built in error handling yet, but we will. We're going to handle that error. Yeah. Right? Okay. Okay. That was problem number 1. Problem number 2 is that we are trying to advance on this token type, right? But it's wanting us to provide a string. So we don't really care like we don't care if the associated string on the token type is correct. What we care about is that its token type is a string. I think the easiest way to fix this is to go back to the scanner. We could do something like in advance on. Right, so there's sort of 2 ways we could do this, right? The fundamental problem is that we want a function that's going to look at the token type and know if we've got the right one. And I think the fundamental problem is that we're storing information in the token type that we really shouldn't be. So one way we could fix this is what we'll do is we go back here, and instead of associating the string literal or the variable name with the token type, we'll sort of have it as an optional field on the token, and that way that information is not like part of the, because I think that's separate from this token type information. The other thing we could do is in Rust, we have control over how partial eq works. We can basically override this equals operator. So we could override it so that token type does not consider associated values when it looks whether things are equal. But I think that's more like a band-aid, and I think fundamentally the problem is this information and this information is not really part of the token type information. I think that's information that's unique to individual tokens. So let's separate it out. Instead of having that, we can have a sort of pub option. If it's a literal string, we'll say if it's a string literal, then it's going to need that string information, and then we'll do the same with variable, right? If it's a variable, then it's going to need a name for that variable, right? So we'll say it's a variable. We'll store the variable name, and then down here. So when we build the token type string, Okay, so we have this token method, and basically it takes a token type and it returns the basically the token, but with the line information set. But now we're adding more context to the token type. So this should take, I guess I guess it will take the string literal that'll be the option string, and it will take variable name, and that will be the option string, and then right, that does the trick for that. And then when we call it, let's have a convenience method. I don't want to pass two nuns every time. Say basic token. Let's be more specific. We'll say command token, and that's going to take an and self and a token type, and it's going to return token, and it's basically going to do what this method did, with the string literal value automatically as none, and the variable token automatically as none. And then, what the heck, while we're here, let's have a function called string literal token that takes the string for the string literal, and will return this. String literal is going to be some string literal, and then the variable name is going to be none because it's not a variable. Now this is getting wonky, isn't it? Because we could have rather than a token struct containing a token type, right? Is this a sign that we should refactor our entire token struct so that the sort of enum wrapper is on the outside? It's a thought, right? We'll go with this for now, and then we may do a video where we refactor this a bit, right? Okay, so we have the string literal token constructor, and then we have a function variable token. Takes right and self, and takes a variable name as a string. Returns a token and does the exact same thing, but the string literal is none, and the variable name is variable name. Ta-da! Great. None of those need to be public. Just not have a super complicated API exposed when we don't have to. And then, okay. So this is basically going to take, this is a variable, so what we want to do is instead of calling a method called token, we want to call self.variable token, and you don't really need to take a token type, do you? You can just take a variable name. And then we can say your token type is token type variable. Right? And then let's, yeah. And then you just take the variable name. Can't find variable name in this scope. Oh, because the variable name is word, is it not? Word. Got two owned. Top notch. And then we have this string. So we'll call it self.string literal token. And you can take result, right? And then you don't have to take the token type either, because we know that the token type is string literal. Token type string. Expected field name, or oh, I called self.self. Whoops. Okay, there we go. What's your deal? Okay, we've got another string. This is how we get the word that we want. So let's call self.string literal token, and we just give it the word. That's better. And then all of these are basically, this is for all the command tokens. And you know what? Do we even need a command token? Because yeah, I don't even think we need this method. I think, yeah, we've covered the string literal and variable name, so we can just sort of get rid of that, and we can call this token. And ooh, we're good. Okay, that's good. Now what I want to do is I want to make sure we're still scanning correctly. So I'm just going to sort of comment this out. Control V. Oops, Control Z. There we go. And you can just return an error tuple automatically, right? And then we won't parse anything, but in lib we're using the scanner. So let's make sure we're still scanning tokens correctly, shall we? Cargo run. Yeah. Right, so we've got so if we look at our script, right, we have a locate token. So locate, it's not a string literal, it's not a variable name. Yeah, I very much see how this would be better. We need to use enums in some way here to get rid of all this nonsense, but it's working for now. And then looks like that's all still working. You know, the strings with the spaces and whatnot. I think we are good. Okay, so now in our parser, this sort of advance on should work, right? We should expect a string. Okay. Mismatch types, expected unit type, found result token, y. Oh, because I do it down here. So we'll say, okay. We're now parsing commands. And if we advance on a locate, then we better get a string to follow it up. It's incompatible types. Cannot convert from token to command. Okay, so advance on error returns the string token, right? So we'll say let locator, right, be that string, and then this is a we want to return a result command, so the command is a locate command with the associated locator. Ta-da! Let's do an else error, just so that stops being mad. Right, expected string, found token. Oh, okay, so we have the token for the string. We could have it take the locator. We could pull the string out of it. We could say dot string literal unwrap. But why not store the token? I mean, I just don't see a right where these take strings. Why not just let's take the token. Let's have the information at our disposal, right? Maybe we'll come back and fix that. Okay. If let some token equal. Okay, so here's the interesting thing. We're parsing a command. Self.advance on type locate. We have this locate token, and we don't do anything with it. That's fine. Right, because we don't really need it. We're just trying to construct. Yeah, we can toss that token, I guess. Okay. Yeah. Let's do the next command. How are we doing on time? Oh, an hour and 24 minutes. Ooh, okay. This could be a long one, folks. What's the next command? Let's else if let's nonsense equal type command. Type. Then that should have some text. So we want to have a string literal. Again, remember, we are eventually going to have we are eventually going to want to use those use variables here as well, but for right now, let's do a string literal. Yeah, it's gonna be buggy for a while, but we'll get there. We'll get there. We want that string, and then we'll say okay. Command type, yeah, with the text token. Cool. What's our next one? Our next one is click. You know what? We've got one more that takes a token, and then the rest will be the same. So let's do it this way. Let's do report. Ooh, I lost my place. Here we are. Let's do a report token, and we're going to say let the log message, right, that they want to report be some string, and then give them the log message, and then let's do another convenience method called advance on any and mute self, and it's going to take token types, right? It's going to take a vec of token types, right? And if we basically we want to be able to give it a vector of token types and just try to get any of them. And we'll say for token type in token types dot iter if let's token equal self dot advance on token type, then we're going to return some token, and then if it doesn't work for any of them, then we're going to return none, right? This wants us to basically clone it, but the funny thing is now in our scanner, token type doesn't have any information, so there's really no reason it shouldn't be copy. And now that should be fine, should it not? Now instead of saying clone, I can just do that, right? Okay, we'll say else if let's token equals self dot advance on. Well, can we do it that way? So click, refresh, try again, screenshot, had error, read to. I think it's going to be easier to do it singular. I was thinking that we could just sort of return the token, but we're going to end up matching on the token type, and it's going to be just as many lines. I mean, here's what I was thinking, right? Advance on any, and then we give it this sort of vec of token type. What are they again? Right? Click, refresh, try again, screenshot, had error, v2. Click, refresh, refresh, screenshot, had error, and then read to. Is that all of them? Click, refresh, screenshot, had error, read to. Click, refresh, try again, screenshot, had error, read to. Try again. Try again. Then we could say something like match token dot token type. And this is just going to be click, refresh, screenshot. See, we're sort of repeating ourselves here. But we always expect a command here, don't we? I think in our grammar, we always want to have some kind of command, right? We'll deal with this, right? So what if advance on any just returns the next token, right? And we'll say just don't take that. Just return the next token. Self dot cur token less an index. Self dot current line dot get the current token. Just that, right? An option. I guess we can map dereference it, right? We want to copy it. It's fine. Call this T. Okay. So basically, we want to we just want to get whatever the next token is. We may be at the end of the line. Then we can just call this, yeah. And then on the next token, we want we're looking for a command that we haven't done yet. So it's not a locate, it's not a type, it's not a report. If it's a click, we want to return OK, command click. If it's a refresh, OK, command refresh. If it's a try again, we want OK, command try again. Well, no, we don't want to try again right there, do we? This is looking at. Oh no, we can do a try again. I don't think a try again is something you want at the beginning of a line. There's going to be all sorts of weird things we have to deal with. Screenshot. Okay. Command screenshot. There we go. Had error. Okay, command had error. Read to takes a variable name as input, so we should have dealt with it here. We've got locate, type, report. Let's do else. Let's basically do all this. Else if let token equals self.advance on token type read to, then we want that to be followed by a string, which is the variable name. We want that to be followed by a variable token, right? Let var self.variable, and then we'll have this command message read to, which has a var token associated with it. And then while I'm here, this needs to say report. That says type, and that says locate. And then read to needs to take a string name to a variable. Associated string is the variable name, right? What's your deal? Oh, your token. You need a token. Cool. Cool. And then, okay. So click refresh, try again. Screenshot had error. Read to is handled. String is handled. Well, no, it's not handled, but it's not something we're looking for. We're looking for a command. So the rest of these and variable EOF, EOL, we don't want to be running into these. So if we have anything else, we want to say this is an error, and we'll sort of enrich that error later on. Sick. What's your deal? Cannot move out of T, which is behind a shared reference. Oh, duh. Token type implements copy. Token does not. This is t.clone. Yeah. Hey, look at that. Okay, so we're probably not doing a very good job right now, but at least we have begun the idea of parsing. So let's go into the lib, and instead of printing out the tokens, let's say we'll call it AST equal parser. Let's use the parser. And new. What did we call it? I think we called it, yeah, we called it from tokens, but then we stopped taking tokens. So let's rename this symbol new. Right, and if we look over in parser, that should be called new now, yeah. New dot parse, and we're going to parse the tokens, And then let's dot expect error parsing, right? And so AST, oh, that's right, you don't return an error. We're going to have an error reporter instead. Okay. So you should be a vec of statements. So let's print it out. We have this scratch UI. Let's reduce it just to this first line to start out, right? Let's run. How are we doing so far? We got, oh, we didn't print them out. For, let's just say, let's do a debug print of the AST. Yeah. Okay, so here we go. We have a statement. So if we look at this, line, we parse this statement. The left-hand side is a locate command with the token for the associated string. The string literal is username, right? And then it has a right-hand side as well, which is another statement. Some token, locate. So left-hand side is this statement. The right-hand side should be another statement, should it not? Some token, token type, and, oh, that's right. The right-hand side is a tuple, an option tuple, so it has the token for the and token, right? Which does not have a string literal or a name. And then it has the statement that follows, right? Which the left-hand side is, see, we have a type command, right? With the associated token being the string that we want to type in. And that text is test@test.com. And then it has the right-hand side to that statement is none. So that appears to be parsing correctly. Wow, what a miracle. All right, let's do the rest. Let's see how we do. We got the one parsed, right? The rest of them, it looks like we got the one line parse. So the rest of them didn't parse. Let's take a look at that. Let's go ahead and print how do you spell whoa? Whoa. Whoa? I have no idea. That's weird. Whoa there. Partner. See if we're getting an error for the other two lines. 3 lines. Good. Okay. Okay, error. Well, so that would be the other 2 lines and then the end of line token. So we'll say or I'm sorry, for the end of file token. So parse statement. Let's do if we'll do this and say while self dot well, we want to say have the current line be that vec and say if self dot current line dot get self dot current token dot unwrap. We're presuming we didn't pass an empty vec to parse. Dot token type equals token type end of line. Then we actually want to break out of this for loop, right? So that should remove one of these errors, I think. Red main panicked on none value. Good, good. Self.current line. So we should be splitting on the end of line token. In the scanner, we are passing, we push an end of line, and then we always push an end of file. So we should get that last vec that we go over should be a length of 1 with just an end of file token, right? So when we split on end of line, line.toVec, self.current line.get self.current token. Oh, you know what? When we are done parsing a statement, then we need to self.current token needs to equal 0, right? And then in, yeah, advance on any needs to self.current token plus equals 1, and then you can do -1 for that, and then advance on or error self.current token plus equals 1. Okay. How are we doing now? Oh, there we go. Okay. So we just have one error this time. So this is our first line, right? Ends in first line ends in password, right? Or no. First line ends earlier than that. Okay, so this is our first line because it ends at test@test.com. This is our second line. It's a statement with a locate command, and then the string, and then the password, and then the right hand side is some and token, and then we have the statement for type. The token is string with the string literal correct, and then the right hand side to that is none. And then we get the third statement. So the third statement is the left hand side is a locate token, and then it has the token type table, right? And the variable name is none, and the right, because it's not a variable. And then for the right hand side, we do have an and token, right? And line 3, and then we have the string literal variable name none, right? Because that's an and. And then we have the statement on the right hand side, which is a read to token, token type variable. The variable name is some my variable, and then right hand side is none. So we actually parsed that entirely correctly. We have correctly parsed a vector of statements to execute. So I wonder where the error is coming from. Let's find out in the next video when we add proper error handling and finish up this parser. Thanks for watching.